Hi folks, this is a short video presentation that is in regard to the CATIA workshops that the Division of Continuing Education is providing. The specific workshops that I would like to talk about are Mechanism Design and Animation, CATIA V5, and the Finite Element Analysis with CATIA V5. My name is Nader Zamani, and I'm a professor of mechanical engineering at the University of Windsor. I'm the instructor of this course, and my area of expertise is computer engineering in general, finite element analysis, with applications in solid mechanics and stress analysis. I have been using CATIA for a while, for the last 16 years, and I've authored several books on the usage of CATIA in engineering applications. In case you want to see how it looked like, it's right there. Now, regarding this course, as a design engineer, you may want to submit your design for an assembly for testing or production purposes. It would be a good idea if you had opportunity to analyze these things for stresses and deformation. Obviously, this is a valuable tool. Let me give you an example of the situation that you may be dealing with. Suppose we have a simple single-cylinder engine, which is shown on the right-hand side, and our objective is to find the stresses that are developed in the connecting rod. The strategy to achieve this is, first of all, you need to know the acceleration of the connecting rod. So you create a mechanism, you apply the RPM of the shaft, the crankshaft, and calculate the acceleration of the different components, such as the connecting rod. And then you take this information along with the material and geometry provided to the FEA module in CATIA. Now, the course that deals with mechanism design and animation is the first stage, namely creating the mechanism and predicting the position, velocity, and acceleration. For example, you can generate the acceleration of the piston, in this case the piston I've shown, and generate a graph like that. This is in acceleration versus time. Here's the velocity versus time. And as a matter of fact, you can create an animation file where the data that I just showed you comes from. Okay? So this is the first course. Now, once you get this information, then you provide it to the finite element module, which is the content of the second workshop. Okay, and in the finite element analysis, you calculate the stresses, or you estimate the stresses and the deformation. For example, if you take the connecting rod, it is shown here. This is part of the assembly that I just showed you. It is meshed, broken down into elements, and some kind of loads are applied. You're going to need the accelerations also, and on the top you see there is a bearing load, and at the bottom there is a surface slider. Here is the generated 1 meter stress within this connecting rod. It's a very simple connecting rod. I understand that, and it's made out of steel. So you see the 1 meter stress shown here, and if you're interested to see the displacement or the deformation, those are shown in the current video. These are all generated in CATIA V5, and the type of problem that we're going to look at the first workshop, mechanism design and animation, and if you're interested in the second workshop, the finite element analysis. The only prerequisite that you need for this course is being able to create simple parts in CATIA V5. Okay? I'm looking forward to see you.